Yes, Rupesh, first of all, introduce yourself before entering into the snap of steel structure. As you have interview in IOCL and date of interview is 28th of September 2022.
Yes, sir. Yes. Good afternoon, sir. I am Rupesh. I am from Nagpur, Maharashtra, and I have an elder brother with my parents. And I have completed my schooling from Nagpur itself. After that, I have completed my B.Tech in civil domain from VJTI Mumbai College in 2020. And after that, I have joined one consultancy firm, Aries Marine and Engineering Services, where I worked as a structural engineer for almost 2 years. And currently, I am pursuing my master's in structural engineering from IIT Madras.
Okay. So can you define what is the difference between wrought iron and cast iron?
Wrought iron and cast iron. Wrought iron. Cast iron is brittle as compared to wrought iron. No, sir, I don't have such idea.
Okay. How will you define steel?
Steel.
Hmm.
Steel is a alloy of zinc and sorry, it is a alloy and it's a material used for mostly construction activities as a reinforcing bar.
So why only steel we are using as a reinforcing material? Why not other?
So the main reason is that the coefficient of thermal expansion of steel and concrete is almost equal. So we can achieve this strain compatibility condition. So it is that's why we are using this steel as a reinforcing material.
Okay, fine. So you must heard about this high strength friction grip bolt.
Yes, sir.
So what is it and how is it different from this black bolt?
Yes, sir. High strength friction grip bolt are more used where reversal of stresses are there, or in that particular this type of bolt, the bearing, the force mechanism is due to some friction virtue of friction between two plates. But in black bearing bolt or normal bolts, the the mechanism of force transfer is due to direct bearing. So that is the difference between them.
Okay, fine. So a bearing stress is what kind of stress?
Bearing stress, sir, it is kind of compressive stress due to direct action of due to direct contact between those 2 points. Suppose for bearing capacity of bolts, so bolt is in contact with whole of that plate. So because of that plate interaction, there is a direct compressive stress in the bolt. So that is a bolt bearing capacity of bolt.
Okay. So what do you think? The bearing stresses are shear stresses or normal stresses?
Uh, Bearing stresses. Normal stress. Sir.
Are you sure?
Yeah, sir, normal stress,
Okay.
compressive stress,
Okay. So can you tell me if we talk about the electrode
electron.
that we are using in the electric arc welding? So how will you choose that electrode for particular grade of electrode we have to use in this welding work?
I think, sir, it depends on the material which we are going to weld. Is the yield capacity or yield strength of that weld material should be more than the parent's material.
Okay. Okay, fine. So Rupesh, one we have a bolted connection,
Yes, sir.
another we have this welded connection. So which one connection you prefer and why?
Sir, it depends on the type of application. For suppose for dynamic loading is there, then we should avoid this weld. Or for fatigue, if it is fatigue is there or reversal of stresses is there, then we should avoid this weld connection. And bolt connection, if we want to release the movement at particular joint, then bolt connection is good. Bolt or rivet connection.
Okay, fine. Now we have this steel truss bridge.
Yes, sir.
Okay, and we have to ensure load always passes through joints.
Joints.
Hmm. That
Yes,
is
sir.
assumption, na? Load always act on the joint in case of the trusses.
Yes, sir.
Okay. So how will you ensure the load always passes through the joints?
Um, for each member, the bending moment, bending stresses should be zero. Means there should be only tensile or compressive stresses in each member of that truss. So if there is a bending moment also, then in the truss, then we can. Hello, am I
Yes, yes,
audible?
yes, you're audible. Rupesh, go ahead.
So if bending stresses are there in particular member, then we can say that it is not a proper truss or ideal truss.
Okay. What is the meaning of this just a rigid truss?
Yes, sir. Sorry,
Just a rigid truss.
rigid,
Just rigid.
just rigid. Just rigid truss. Maybe I think at particular point, maybe it will transfer movement also. I think I am not sure. Rigid truss means joints are rigid. I think. Not sure, sir.
Okay.
Not sure.
How will you define the this static indeterminacy of the truss, or in short, if we have to just tell that the truss is determinate, then how can you say that one? On what basis?
Sir, directly there is formula for that because in trust for each joint we have only one this yes, we have only 2 degree of freedom for each joint. So if we directly go through formula, so it is m plus r minus 2j for 2d and m plus r minus 3j for 3d. So where m is the number of members in the truss, r is the number of reactions, external reaction, and j is the number of joints. So if it is 0, then we can say it is a statically determined stress. If it is greater than 1, then or greater than 0, then it is statically indeterminate stress. And if it is less than 0, then it is unstable or unstable stress.
Okay. So you must heard about purlin.
Berlin, yes, sir.
So what is it? And if we have to design purlin, then what type of member we have to consider?
So Berlin is a one member along the length of the this roof truss. It is a main member on the top side of the truss, and for its design, we should use channel section.
Channel section. And
Yes,
if
sir.
we talk about the leap of channel, so what do you think? So you will place
Leap.
the channel leap.
Yes.
What do you think? You will just place the channel in such a way the leap this face towards the ridge, or this back of the channel face towards the ridge. What do you think?
No, no. Leap of channel towards the downward side, means towards the truss.
Can you draw on paper and show it to me?
Yes, sir. Sir, are you able to see?
Yes, yes. So in this way, how can you put the purlin?
Sir, this is along the this length, outside length. So
Hmm?
this is a purlin section, channel section.
So you place purlin on what things? What are the things that are supporting the purlin?
Principal draft.
So what do you think? The rafter is above the purlin, or purlin is resting on the?
Okay, purling should rest on that principal draft.
Okay, just
So
hold on. Okay,
it should
just
be opposite
give me
direction.
give me this. Just wait for 30 seconds, Rupesh.
Yes, sir. Yes,
So till then, just correct yourself.
yes, sir.
Yes, Rupesh.
Yes, sir. This.
Yes.
Is it?
Okay. Fix. Don't move it. Yes. Otherwise, this is not focusing the things. No, this is just focusing your pen only. No. Okay. Anyhow, I just see it. This time you did little correction, but this is not properly corrected. Okay. See, Rupesh,
Yes, sir.
the this your channel, what we call it, this
Yes.
purlin. Its lip is generally turned towards the ridge.
What's the reach? Okay.
Yes. What you did, you just make it the back of the.
Back of the reach. Yes.
Hmm.
Yes, sir. So it is. It should be like in opposite direction, correct?
Hmm. Yes. It is. This is not clearly visible to me. I'm just showing to you this one. See now.
Yes, sir.
Is it visible to you?
Yes, sir. Yes, sir.
I just make the half portion. This is kind of the pink truss that we have, pink roof truss. This
Yes,
point
sir.
is the, this one is the, okay, let me make it, here, this is a ridge,
Reach.
and you can see channel section.
Channel section.
Its
Yes,
lip
sir.
is towards the ridge. This is for the
Yes.
stability purposes.
Okay, sir.
Okay. Now, second portion is that if we talk about this purlin section, so what member we are taking it for the designing?
Early.
Purlin.
What member is
Like compression member, tension member, bending member. What do you think?
um, sir, it is bending member.
Are you sure? Yeah, this is bending member. You're right. Which one code is saying you have to design the this purlin as a flexural member?
Which code?
Hmm.
IS 800 2007.
Yes, this is a code for the steel structure.
Steel structures. Yes.
Yes. So can you tell me what is the difference between this plate girder and gantry girder?
Plate girder and gantry girder.
Hmm.
Plate girder, sir, these girders having web depth is more, and gantry girder, I think it is required to support the gantry for any crane purpose or anything. Plate girder, it is normally used as a beam, or it can be used as a normal beam, structural beam.
Okay. So what do you think? The built-up beam and plate girder both are same or they are different?
The beam and plate girder.
Hmm.
I think plate girder is a built-up section.
Okay. So why stiffeners are being provided in plate girders?
Sir, actually depth of wave is more, so maybe to provide lateral stability against torsional moment or anything. Maybe that's why we are we are giving this stiffness to the plate guard.
Have you ever seen the this what we call them this stiffeners in the plate girder? Practically, have you ever seen?
Practically, yes, sir. Yeah,
So we have this such vertical stiffeners and horizontal stiffeners.
yes, sir.
Any design criteria you remember regarding this one? So what is the minimum spacing between the stiffeners?
Stiffness.
Hmm.
No, sir, no idea. It should be half of distance between both sides. I
Okay.
don't have
Okay, fine. My last question, आपसे रुपेश. What is this shape factor?
shape factor.
Hmm.
Yes, sir. Actually, it is a ratio of MP plastic moment by yield strength or yield moment, or ZP by ZD. that is plastic section modulus or divided by elastic section modulus. So it shows the reserve of strength of any member after it starts yield.
Suppose the shape factor is 1.5, then what it mean?
So it means the cross section is a rectangular section, and it is having 50% more strength from the point when it starts yielding. So it can take 50% more moment.
Okay, fine. So let me provide you feedback, Rupesh. So what I ask you, just have a look on the what is the difference between this wrought iron and cast iron.
Okay, sir.
Okay, just check that one, because basically when we are working with the tools, we have this wrought iron that has been heated and converted into the tool, and cast iron is that iron that has been melted, poured into a mold, and it is allowed to this what we call this solidify. But there are some applications in wrought iron. Basically, the carbon content is low. What
Okay.
carbon content we have in case of the cast iron? Okay, I just want to know the basic difference point. So
Yes, sir.
that question came in my brain. So I just want to know whether you have the idea of that or not. Okay, what is steel? See, steel is an alloy. Rupesh,
Yes, sir.
at least you have to this specify, sir. Steel is an alloy. So more than 98% we have iron. Small percentage of carbon is there, and other elements like chromium, nickel are there. Even sulfur is there. You know? So
Yes, sir.
whenever we are going with the stainless steel and chromium and this nickel content is more, but we have this chromium and nickel content in the normal steel. Okay,
Okay, sir.
and bearing stresses are your this normal stresses.
Yes.
They are compressive in nature. That was fine. So what is the meaning of the just rigid truss? So just rigid truss is nothing but this is statically determinate truss. Rupesh, इसको नाम दिया हुआ है.
Yes.
Okay, this was the recent question asked by the UPSC.
Okay.
Just rigid truss. Okay, so statically determinate truss, you just told to me the formula that was okay, m plus r minus 2j for 2D truss and m plus r minus 3j for
3J.
the 3D truss. That is
3D.
a space truss or plain truss. 2D truss is a plain truss and 3D truss is a space truss.
Yes. Yes.
And purlins, just see one thing, the purlins we can use angle section also, channel section also. So just you can add a few things here. Sir, we are also using the cleat angles to support this channel section from its back side.
Yes, sir. Cleat angle.
Okay. Have you ever seen this cleat angle?
Yes, sir. Yes, sir.
So this is the cleat angle. So I just modified it little.
There. Yes, yes. But
Okay.
yes, sir.
They are also going along the length basically. No?
Yes, sir.
So we are just using the tie rod or sag rods to just minimize or prevent the deflection in the this purlin section, because we are taking the purlin as a flexural member as per the IS 800 2007, and this
Yes,
is
sir.
continuous beam.
Yes, sir.
Continuous beam, this purlin section will last more than 2 trusses.
Okay.
2 से ज्यादा ट्रस के ऊपर जाएगा ये, है ना,
Yes,
पर्लिन.
sir.
Fine.
Yes, sir.
And rest of things, yes, plate girder and gantry girder. You just little hit the answer. So you can say, sir, both are the flexural member. First of all, plate girder and gantry girder, and they are serving the different purposes. The things that you said, that was okay. And sir, in case of what we have built up beams, so we are just making the beams by joining the top flange plate, bottom flange plate with the vertical plate that we call it the web plate. But when the loads are more, we require more section modulus, because section modulus is the bending strength parameter for the beam. So in that case, we are going with the greater depth. So we have the plate girders, and we never want the buckling of web will take place. So we are stiffening the web also with the help of the stiffeners. Vertical stiffeners are there, horizontal stiffeners are there, so that we are providing to prevent the buckling of the web. And sir, when load is more, or even load is same but the span is more, because if span is large, then deflection will also be large. Suppose a simply supported beam having a point load at its center, WLQ 148 EI. So if span is more, its length का cube हो रहा है, तो deflection बहुत ज़्यादा बढ़ेगा. So in that case, we are going with the truss girder. Truss we have. Even truss bridges, you must see in the railways or highways, the trusses we are using as a girders. So more than 100-meter span, then we are using the truss as a girder. Fine, as a girder. And less than 100-meter span, so we are just using this plate load, sorry, plate girder. The section is I section basically. Okay, and rest of thing is fine. So anything else, Rupesh?
सर स्पेसिंग का क्राइटेरिया पूछा था आपने, स्टिफनेस स्पेसिंग.
Minimum spacing कितना होता है? So what is the clear distance that we have in the plate girders? That is उसका 1/3 हम use करते हैं, 1/3.
Okay. Clear
Two things
distance.
are there: this clear depth of the web, and when we are just using top plate, suppose this is a top plate,
Yes, sir.
bottom plate, this is a kind of the web plate. So now these are the steel members,
Yes,
steel
sir.
top plate, and this is also steel bottom plate. So now just let me tell you. So here we have to use the angles also to join them if we are not doing the welding. So in short, we have the bolted plate girder. Okay, so what angles we have? So at the toe of one angle, that is the top flange plate के साथ जो जुड़ा हुआ है, and the bottom flange plate के साथ जो angle जुड़ा हुआ होगा as a fasteners. So उनके toe to toe के बीच में जो gap होगा, distance होगा, that is your clear distance of the plate girder, या clear depth of the plate girder. Different depth we have, na, clear depth we have, effective depth we have. So we have to take care in this case. Okay, even we have this web equivalent in the tension zone, web equivalent in the compression zone, and generally this web equivalent in the tension zone is more what we have in compression zone. Reason is that in tension we have to take care of the shear lag effect, so we have to reduce the area by considering the reduction of area for the holes. But in compression zone we are not considering that, because the main design issue for the tension member is the shear lag effect. Okay, and maximum is 1.5 times.
Okay.